For 4,000 years, thousands upon thousands of clay tablets have been sitting in darkness, carrying words that almost nobody alive today can read. Some were written by accountants, some by kings, some by priests, some by students who made mistakes while learning how to write. And some contain stories about creation, war, disease, death, gods, floods, kings, and the terrifying idea that human beings were never meant to live forever. For generations, recovering those words depended on a tiny number of specialists who could spend decades learning a writing system containing hundreds of signs and languages that disappeared thousands of years ago. But that barrier is beginning to crack. New machine learning systems are now being trained on enormous digital collections of cuneiform, including a newly released 2026 dataset containing more than 91,000 Sumerian tablets and nearly 7 million recorded glyphs. Other systems can already recognize ancient cuneiform signs automatically and assist with translation of Akkadian texts. And suddenly, a question that sounded impossible is becoming real. What happens when machines can search the surviving written record of ancient Mesopotamia faster than any human team ever could? The answer is not that AI has proved aliens built civilization. It has not. The real danger is more interesting. Machines may discover connections between thousands of ancient texts that scholars have never had the time or tools to compare. And when those connections emerge, they could force us to rethink what the earliest literate civilization actually knew, what it believed, and what it was trying to preserve. The people responsible for some of the oldest surviving writing lived in southern Mesopotamia, in the region of modern Iraq, where the Tigris and Euphrates created an environment capable of supporting dense settlements. By the late 4th millennium BCE, administrators in cities such as Uruk were using clay tablets to record commodities, professions, quantities, and transactions. These earliest tablets do not read like modern books. They are records of an economy becoming too complicated for memory alone. A farmer could produce grain. A temple could collect it. Workers could receive rations. Merchants could transport goods. Officials could redistribute resources. Once the number of people and transactions became large enough, someone needed a durable way to remember who owed what to whom. Clay provided the answer. The earliest cuneiform was therefore born from administration, not from a desire to write mythology. That detail matters because it explains why so many tablets are ordinary. The ancient Mesopotamian archive is not dominated by legends. It is filled with the paperwork of civilization. The astonishing stories survived alongside receipts, inventories, contracts, school exercises, property records, and lists. Modern researchers are only now developing the computational tools needed to examine these materials at enormous scale. Cuneiform itself was not one language. It was a writing system. Sumerian was one of the earliest languages recorded with it, and later scribes adapted cuneiform to Akkadian, a Semitic language, and eventually to other languages of the ancient Near East. The system used word signs, syllabic signs, grammatical markers, and many variant sign forms. Depending on the period and context, the same sign could represent different words or sounds. According to digital cuneiform projects, hundreds of sign forms were used across the history of the script, while scribal traditions changed their appearance and functions over centuries. A tablet, therefore, cannot simply be read from the shape of one symbol. Researchers must identify the sign, understand its historical form, determine the language, reconstruct grammar, check the context, and compare the result with parallel texts. One damaged wedge can change the meaning of an entire sentence. A missing line can remove the verb. A broken edge can erase the name of a king. A sign that looks like one word in isolation may mean something completely different when placed inside a particular grammatical construction. This is why cuneiform translation has traditionally required years of specialist training. Now imagine putting a machine into that world, not a machine that magically understands Sumerian like a human speaker, because there are no native speakers left to teach it. Instead, imagine a system trained on every trustworthy transliteration and translation researchers have already published. It can compare sign sequences across tens of thousands of tablets. It can identify repeated phrases. It can search for rare words. It can group texts by linguistic patterns. It can compare the way one sign was used in Uruk with how the same sign was used hundreds of years later in another city. It can even help researchers reconstruct damaged fragments by comparing them with known textual formulas. That is already beginning to happen. In 2026, researchers released Some Tablets, a dataset pairing digital representations of more than 91,000 Sumerian tablets with their scholarly transliterations, containing almost 7 million glyphs. The researchers used the dataset to test machine learning approaches to transliteration and reported very high character level performance for a fine-tuned language model. That does not mean a machine has become fluent in Sumerian. It means the barrier between ancient handwriting and computational analysis has finally started to break. And that is where the real story begins. Because the biggest secret hiding inside the tablets may not be one shocking sentence. It may be the relationships between thousands of sentences. A human scholar might spend years studying one category of texts: mathematics, medicine, law, astronomy, mythology, administration. Another scholar might specialize in lexical lists. Another might focus on royal inscriptions. Another might reconstruct damaged fragments. But an AI system can search across all those categories at once. It can ask whether the same unusual term appears in mathematical texts and medical texts. It can find whether a particular expression used in a myth also appears in an administrative document. It can trace a word across centuries and cities. It can detect phrases that appear to migrate from one language into another. Those connections can reveal how knowledge moved through ancient society. And when that happens, the machine does not have to invent a mystery. The mystery is already there. We simply did not have the computational capacity to see its full shape. One of the most important areas for this kind of research is astronomy. Ancient Mesopotamian scholars watched the sky continuously. They recorded lunar observations, planetary appearances, eclipses, stars, and seasonal events. Later, Babylonian astronomers developed sophisticated mathematical methods for predicting celestial phenomena. Their records are among the oldest surviving examples of systematic astronomical observation. But there is a temptation to turn every ancient astronomical record into evidence of modern science arriving thousands of years early. That is where caution matters. The Mesopotamians were extraordinary observers, but they understood the heavens through a mixture of empirical observation, mathematics, divination, religion, and political interpretation. A celestial event could be carefully recorded and simultaneously understood as an omen. Those two ideas were not contradictory in their worldview. The sky was physical and meaningful at the same time. AI could help reconstruct this tradition more completely by comparing thousands of astronomical statements and identifying patterns that individual scholars might overlook. But it should not be expected to transform Babylonian astrology into modern astrophysics. The same warning applies to one of the most frequently exaggerated claims in ancient history videos: the idea that Sumerian texts describe Earth's precession over a period of roughly 26,000 years. The Earth's axis really does precess, and the cycle is real. Ancient observers certainly noticed long-term changes in the relationship between stars and the horizon, but that does not mean Sumerian scholars possessed modern knowledge of axial precession in the scientific sense. Some ancient astronomical texts preserved observations over generations, but the claim that Sumerians explicitly calculated the full modern precessional cycle is far stronger than the evidence allows. AI could help researchers compare star observations across centuries and determine how ancient scribes described changing celestial positions. That would be fascinating. But a machine should not be allowed to turn poetic or omen language into a modern scientific equation simply because the pattern looks impressive. Mathematics provides a cleaner example of what the ancient texts genuinely contain. Mesopotamian scribes used sophisticated numerical systems, especially a sexagesimal tradition based around 60. Mathematical tablets preserve multiplication and reciprocal tables, calculations involving areas and volumes, problems involving practical administration, and geometric reasoning. Later, Babylonian mathematics became capable of methods that modern readers can recognize as algebraic. This was not primitive arithmetic, it was a sophisticated scribal discipline. Digital projects have already published and translated around 1,000 mathematical cuneiform tablets, while many more remain to be analyzed. AI could accelerate this work by identifying repeated mathematical structures, matching fragments, classifying problems, and tracing how methods change between schools and periods. The exciting possibility is not that computers will discover secret formulas showing that Sumer had modern physics. It is that they may reveal how ancient mathematical knowledge actually developed from generation to generation. Medicine presents another enormous opportunity. Mesopotamian medical texts contain descriptions of symptoms, treatments, diagnostic procedures, plants, minerals, oils, and ritual actions. Some treatments involve ingredients that have plausible pharmacological effects. Others rely on magical or religious procedures. Modern readers sometimes separate those categories too sharply because modern medicine is based on a different intellectual framework. The ancient healer did not necessarily see a contradiction between administering a physical remedy and invoking a protective deity. Both could be part of treatment. AI could help map the vocabulary of these texts. It could identify every appearance of a particular plant name. It could compare symptoms across different periods. It could identify recipes that were copied for hundreds of years. It could even reveal that words traditionally translated as unrelated substances actually belong to the same botanical family. That could produce genuinely new research questions. But once again, the machine would need specialists to verify what it is reading. This brings us to one of the most important facts about AI and ancient languages. Ancient language AI is usually not learning the language from scratch in the same way a child learns a living language. It is trained on information produced by scholars. transliteration datasets, dictionaries, translations, sign lists, grammatical analyses, and published editions become the training material. That means the machine can inherit both the strengths and the limitations of modern scholarship. If a traditional translation is wrong, incomplete, or controversial, the model may reproduce the problem. If a particular category of text is overrepresented in the training data, the model can become better at that category and worse at another. If damaged tablets are excluded because no reliable translation exists, the most mysterious material may remain invisible to the machine. AI, therefore, does not eliminate human bias. It can scale. The goal is to use computation to expose uncertainty, compare alternatives, and accelerate verification rather than hiding the assumptions inside an apparently authoritative answer. Recent work shows exactly why that caution matters. A legal tablet preserves a rule. A royal inscription preserves political memory. A myth preserves cultural values. An astronomical record preserves observation. A school exercise preserves a teaching method. Together, these objects form a distributed memory system. The clay tablets are effectively the hard drives of the ancient world. They were small, they were cheap, they were durable, and unlike many organic materials, fired or dried clay could survive thousands of years. That is why we know so much about Mesopotamian administration. We can read the names of workers, we can see what they were paid, we can identify shipments of grain, we can reconstruct temple economies, we can observe how government systems functioned. This is a civilization talking to us through paperwork. And now AI is giving us a way to search that paperwork at a scale impossible for one scholar. That is the real technological leap. The Sumerians created a machine for remembering. We are building machines for searching that memory, and somewhere inside that enormous archive are discoveries that nobody has made yet. Maybe a forgotten medical recipe, maybe a missing section of a famous myth, maybe a mathematical technique, maybe a record of a flood, maybe a list of ancient plants, maybe a contract that reveals how ordinary women owned property, maybe a previously unknown language, maybe a political crisis, maybe a migration, maybe nothing dramatic at all. But any one of those could change the way we understand the ancient world. Because history is not only changed by spectacular discoveries, sometimes one corrected word is enough. One name, one date, one place, one sentence, and one connection between two fragments. That is why the current AI revolution should be watched carefully. Not because machines have already revealed that Sumerians were hiding extraterrestrial secrets. They have not. But because for the first time, we have computational tools capable of looking across a written archive that is far too large for one generation of scholars to examine manually. The archive is still there. The clay still exists. The signs still exist. The words still exist. And the unanswered questions are enormous. What knowledge was lost between surviving tablets? Which stories were copied from even older sources? Which mathematical techniques were forgotten? How much medicine was based on plants whose identities we no longer know? How did ancient scholars track the sky? How did languages change? How did people understand disease? How did ordinary people experience political power? And what did ancient Mesopotamians actually believe about themselves? Those questions are real, and AI can help. But the machine will not be the final authority. The final authority remains the evidence, the tablet, the archaeology, the language, the context, the independent verification. That may not sound as dramatic as AI just decoded an alien message, but it is much more dangerous to underestimate what the real evidence can do. Because if a machine connects two ancient fragments and proves they belong to one forgotten literary work, that is history-changing in real time. If it identifies a mistranslated term that has shaped scholarship for generations, that is history-changing. If it reveals that a supposed mythological phrase was actually an administrative technical term, that is history-changing. If it helps reconstruct a damaged astronomical record and scientists discover a previously unknown observation, that is history-changing. And none of those discoveries require aliens. They require something much harder: patience, evidence, and the willingness to accept that the ancient world may have been more complicated than any modern theory about it. So the most important question is no longer whether AI can translate Sumerian. It can already assist with parts of the process. The question is what it will discover when the entire surviving corpus becomes computationally searchable. What happens when tens of thousands of tablets can be compared simultaneously? What happens when a phrase hidden in a museum drawer is automatically connected to another fragment stored on the other side of the world? What happens when a forgotten word suddenly appears in hundreds of different contexts and its meaning becomes clearer? What happens when a famous story gets reconstructed from fragments that nobody realized belonged together? That is where the real mystery begins. Because the Sumerians did something extraordinary. They left evidence. Not legends passed through thousands of years of oral retelling. Not stories reconstructed from memory. Physical tablets, physical marks, physical words. And those words survived. The civilization that wrote them disappeared. The cities collapsed, the temples became ruins, the languages died. But the clay remained, and now, after thousands of years, machines are finally beginning to listen. They are not listening to aliens, they are listening to humans. And what they hear may be enough to change history. Because perhaps the most unsettling discovery waiting inside those tablets is not that Sumer knew something impossible. Perhaps it is that the people who lived 6,000 years ago were already doing something we still do today. They were trying to understand the universe. They were trying to organize society. They were trying to cure disease. They were trying to explain suffering. They were trying to understand death. They were trying to preserve knowledge. And above all, they were trying to make sure that something of them survived. They succeeded. A farmer's name, a merchant's debt, a student's mistake, a king's order, a priest's prayer, a mathematician's calculation, a poet's story. All of it pressed into clay, all of it waiting. And now machines are helping us open that archive. The real danger is not that AI will tell us something impossible. The real danger is that it may reveal how much of the ancient world we have misunderstood. And once those forgotten words begin speaking clearly again, some of the stories we have repeated for centuries may not survive the translation. Because history belongs to the evidence. And the Sumerians left more evidence than almost anyone who lived before them. Now we finally have the tools to search it. Machine learning researchers have been developing systems that recognize cuneiform signs automatically. A 2025 study of old Babylonian texts reported strong classification performance on signs with enough training examples, while also demonstrating how much performance can depend on the dataset and the way tablets were digitized. Other recent projects have used AI for ancient language translation and reconstruction. These are legitimate advances, but they are still tools. They do not mean an AI can translate any tablet flawlessly, especially a damaged Sumerian tablet never included in a training set. In archaeology, the last 5% of accuracy can matter more than the first 95% because the rare, disputed line is often exactly the line people want to use to support a sensational theory. Then there's the question that makes this whole story so seductive. What if the texts contain something that sounds like modern technology? This is where ancient language AI could either make history more accurate or make internet mythology explode. Consider the Sumerian creation stories. In Atrahasis and related traditions, humanity is created from earthly material mixed with divine substance. The language includes ideas of birth, creation, blood, clay, labor, and reproduction. Those themes are genuine. But translating divine essence into a modern term such as DNA would be a huge interpretive leap. Ancient people understood inheritance, lineage, birth, and blood. They did not need molecular genetics to have sophisticated ideas about ancestry. When an AI system encounters an ancient metaphor, it may produce a modern-sounding phrase because modern English contains words that do not exactly correspond to the ancient concept. That is precisely why translation needs context. The Anunnaki create an even bigger problem. In actual Mesopotamian texts, the Anunnaki are gods. Their roles vary across periods and traditions, but they are part of the divine world of ancient Mesopotamian religion. They are not described in the original Sumerian corpus as extraterrestrial astronauts arriving from another planet to genetically engineer modern humans. That interpretation became famous centuries later, especially through the writings of Zecharia Sitchin. Professional Assyriologists have rejected Sitchin's readings as incorrect. The ancient word Nibiru appears in Mesopotamian astronomical texts, but its meaning depends on context and does not provide evidence for a hidden planet with a 3,600-year orbit carrying alien miners to Earth. If AI produces a translation that seems to support Sitchin, the proper response is to compare the original signs and grammar, not assume the machine has overturned Assyriology. The Baghdad Battery creates another perfect trap for sensational storytelling. Archaeologists have found a particular type of vessel near Baghdad containing a copper cylinder and iron rod. And experimental reconstructions show that an acidic liquid could generate a small electrical potential in such an arrangement. That is real. But the function of the artifact remains uncertain, and its date places it far later than the earliest Sumerian civilization. It therefore cannot be used as proof that Sumerians were manufacturing electrical batteries. More importantly, there's no verified cuneiform text describing an electrical generator. If an AI translation system encounters words that a modern translator renders as glow, copper, or vessel, that does not automatically mean electricity. Ancient descriptions of lamps, furnaces, ritual vessels, metals, and divine light can sound technological when stripped from their cultural context. The question is not whether a modern reader can imagine electricity. The question is whether the ancient language actually specifies an electrical process. Another source of fascination is the Sumerian king list. Some of its earliest rulers are assigned reigns lasting thousands or tens of thousands of years. That sounds impossible, and it is tempting to treat the numbers as evidence of lost knowledge. But the structure of the document offers a much simpler explanation. The earliest rulers occupy a mythic period before the flood, while later kings have increasingly ordinary reign lengths. This transition from divine or legendary time into human-scale history is common in ancient literature. The enormous numbers may also reflect Mesopotamian numerical symbolism. Instead of treating those reigns as literal biographies, researchers examined how the numbers function inside the text. An AI system could be extremely useful here by comparing every surviving copy and identifying numerical changes across manuscripts. That could tell us whether the numbers were standardized, altered, or transmitted with scribal variation, and that leads to a much more interesting possibility. What if AI does not reveal one secret about Sumer, but reveals that some famous texts have been mistranslated for generations? Imagine discovering that a word commonly translated as king actually has a narrower political meaning. Imagine learning that a particular plant name was misunderstood. Imagine realizing that a famous myth contains a phrase that changes the chronology of an event. Imagine connecting fragments from different museums and discovering that they belong to one document. Those kinds of discoveries could genuinely rewrite history because they would be based on the original evidence, not on speculation. In fact, fragments may be one of the biggest opportunities. Tens of thousands of cuneiform pieces remain in collections. Some are tiny. Some are unprovenanced. Some were discovered during early excavations, when recording standards were different from modern practice. Researchers may know that several fragments probably belong to the same period without knowing whether they came from the same tablet. AI can search shapes, sign sequences, language patterns, and textual formulas simultaneously. It can generate candidates for joins. A human researcher can then inspect the original objects and verify the connection. This is the digital equivalent of discovering that 2 pages in different libraries belong to the same lost book. The Fragmentarium project at Ludwig Maximilian University in Munich is part of this broader transformation. Researchers are digitizing large collections of cuneiform and using computational methods to connect fragments. The goal is not to replace historians. It is to make an enormous archive searchable. Nature has highlighted this wider movement as part of a growing wave of AI-assisted ancient text research. The same technological revolution is affecting other writing systems too, from damaged Roman papyri to ancient scripts that were previously inaccessible. What is happening in Mesopotamia is therefore part of a much larger transformation in archaeology. Machines are becoming tools for reading physical evidence that humans alone cannot process at scale. But there is a darker side to that transformation. The more persuasive machine translations become, the easier it will be to manufacture historical misinformation. A person could take a damaged tablet image, feed it into a language model, ask for the most likely hidden meaning, and receive a fluent paragraph. That paragraph could sound scholarly. It could mention Anunnaki, genetic engineering, cosmic cycles, energy vessels, or lost technology. Viewers might believe it because the output looks technical. But unless the reconstruction is independently verified, it is not evidence. This is going to become one of the biggest challenges in digital archaeology, separating machine-generated possibilities from archaeological facts. The danger is particularly high because cuneiform already has a massive online mythology attached to it. For decades, books and documentaries have claimed that Sumerians described astronauts, nuclear weapons, genetic experiments, advanced spacecraft, and forgotten planets. Most of those claims rely on mistranslations, selective quotations, or comparisons that ignore the actual linguistic context. AI could make these myths weaker if used responsibly because researchers can test the claims against enormous corpora. But AI could also make them more dangerous by generating polished explanations that sound authoritative. The same technology capable of correcting an old translation can also invent a new mistake faster than a human scholar can correct it. That is why one of the strongest things a legitimate AI-assisted Sumerian project can reveal is not certainty but disagreement. Imagine a system highlighting 3 possible readings for a damaged passage. Instead of telling the user one answer, it shows how each interpretation changes the meaning. One reading might describe a ritual, another might describe an administrative action, a third might be grammatically possible but historically unlikely. That would be an enormous improvement over simplistic translation. Ancient language scholarship is often about managing uncertainty. A good machine should make that uncertainty visible rather than hiding it. There's also a deeper problem with the phrase, "they just translated Sumerian." Sumerian was used for a very long time and its written form changed. Later, scribes sometimes preserved old texts by copying them into new contexts. A tablet from the Old Babylonian period can preserve an older Sumerian composition. A bilingual lexical list can explain Sumerian terms using Akkadian. Scholars in later periods treated Sumerian almost like a classical scholarly language. That means a single text can contain layers of history. The oldest surviving copy may not be the moment when the story was originally composed. An AI system has to account for that transmission history, or it may incorrectly date a concept to the wrong period. This is especially important when people claim that AI discovered modern scientific knowledge inside a 4,000-year-old tablet. Even if a later Babylonian text contains a sophisticated astronomical calculation, that does not mean the method originated in the earliest Sumerian period. Mesopotamian knowledge accumulated over centuries. Sumerian, Akkadian, Babylonian, and Assyrian scholars inherited, translated, modified, and preserved one another's traditions. Calling all of that Sumerian science collapses a civilization that lasted for millennia into one imagined technological culture. The reality is much more interesting. Knowledge evolved. The same applies to writing itself. Cuneiform did not remain unchanged from its invention until its disappearance. Early administrative signs from Uruk look very different from the developed script used in later literary tablets. The number of signs, their shapes, and their uses changed. Scribes developed traditions for copying and teaching the script. Lexical lists were used to preserve sign meanings. In some schools, students learned long lists of professions, animals, plants, and objects. Those lists were not just dictionaries, they were educational systems. The ancient scribes were building their own knowledge infrastructure. AI can potentially reconstruct that educational system. Imagine mapping every known school tablet. You could see which signs students learned first, which errors were common, which words were grouped together, which mathematical problems were taught at which level, which cities produced particular scribal traditions. You could even reconstruct the intellectual curriculum of ancient Mesopotamia. That is much more exciting than an invented story about alien engineers, because it tells us how humans learned. And that brings us to the biggest revelation. The Sumerians did not simply invent writing. They invented systems for preserving knowledge. A sign list preserves vocabulary. A mathematical table preserves calculations.